Two Toyota Camrys, same engine, same mileage, same driving conditions for 2 full years. One ran nothing but Toyota's factory fill oil, straight from the dealership, every interval, by the book. The other ran a premium full synthetic, changed on the same schedule, same filter brand, same driver, same routes. Then we pulled both engines apart on the bench and looked at what 2 years of real driving actually does to metal. What we found wasn't what we expected, and it's going to change how you think about that little sticker on your windshield that just says 5,000 miles or synthetic blend. Let's set the stage first, because context matters here. Both cars were the same generation Camry, both running the 2.5-liter 4-cylinder, both purchased within weeks of each other with single-digit mileage. Car A stayed on Toyota's factory fill oil, which for this engine is a low-viscosity synthetic blend rated 0W20, sourced through the dealership at every service. Car B was switched to a full synthetic 0W20 formulated with a higher percentage of PAO base stock and a heavier additive package, the kind you'd find in a premium bottle rather than a bulk dealership drum. Everything else stayed identical. Same filter, same mileage intervals, same driver behavior logged through a simple trip journal, and both vehicles parked side by side in the same garage. 2 years, roughly 24,000 miles each. Then both engines came out, got fully disassembled, and every major wear component got measured, photographed, and compared side by side. Finding number 1, the piston rings told a different story than we expected. On Car A, the factory oil engine, the compression rings showed light but visible carbon glazing along the ring face, especially on cylinders 1 and 4, which tend to run slightly hotter due to their position in the block. The ring gap, measured with a feeler gauge against factory spec, had opened up marginally more than Car B, but we're talking about a difference of roughly 0.02 of an inch. Not catastrophic, not something that would show up as a performance issue at this mileage. Car B's rings looked cleaner, less carbon buildup, slightly better oil control based on the condition of the oil control ring's drainback holes, which were noticeably less clogged. The synthetic oil's stronger detergent package appeared to be doing its job, keeping carbon from baking onto the ringlands. But here's the part that surprised us. The difference was smaller than the marketing for full synthetic oil would have you believe. We expected a night and day gap. What we got was a modest, measurable edge for the synthetic, not a dramatic one. Finding number 2, the cylinder walls, or more specifically, the cylinder bores, held the biggest surprise of the entire teardown. Using a bore gauge, we measured taper and out-of-round wear at multiple points down each cylinder. Toyota's 2.5-liter engine uses a cast iron sleeve pressed into an aluminum block, and that liner is what actually takes the wear from the piston rings, sliding up and down thousands of times per minute. Car A showed slightly more crosshatch wear pattern erosion, meaning the fine machining marks left by the factory honing process were more worn down and less visible under magnification. Car B retained more of that crosshatch pattern, which matters because that pattern is what holds a thin film of oil against the cylinder wall during the compression and power strokes. But the actual bore diameter measurements, the number that tells you if the cylinder has actually worn oversized, were within 0.005 of an inch of each other. Statistically, that's close to the margin of measurement error on a standard bore gauge. In plain terms, both engines were still well within Toyota's factory tolerance for cylinder wear at this mileage, synthetic or not. Finding number 3, and this is where things got interesting. The camshaft lobes and the associated valve lifters showed almost no measurable difference between the two engines. Toyota's overhead camshaft design on this engine uses roller-type rocker arms with hydraulic lash adjusters, which dramatically reduces the metal-on-metal sliding friction that older flat tappet designs suffered from. Because the rocker arm rolls against the cam lobe instead of sliding, the oil film requirement is far less demanding, and both oils, factory fill and full synthetic, protected these components equally well. This tells you something important. On modern Toyota engines with roller-type valvetrains, the camshaft is one of the least likely places to see a meaningful difference between oil grades, because the mechanical design itself has already solved most of the friction problem before the oil even gets involved. Finding number 4, the timing chain and its tensioner. This is a component Toyota engineers specifically overbuilt because a stretched timing chain can throw off valve timing and trigger a cascade of drivability problems. We measured chain elongation on both engines using a chain wear gauge against a fresh reference chain. Car A's timing chain showed marginally more stretch, roughly the difference you'd expect from maybe 3,000 to 4,000 additional miles of wear equivalent, even though both cars had identical mileage. The timing chain guides, which are plastic composite pieces that the chain rides against to control chain slap and vibration, showed slightly more surface wear on Car A as well. Neither engine was anywhere close to a failure point. Toyota's timing chains on this engine are rated to outlast the engine itself in most cases. But if you're looking for where full synthetic oil earned its keep, the timing chain assembly is a legitimate answer, because that thinner, more thermally stable synthetic film handles the high-load, high-friction contact between chain and sprocket a little better over time. Finding number 5, rod bearings and main bearings, the components that most people worry about most and understand least. These are the bearings that support the crankshaft and connecting rods, and they rely entirely on a pressurized oil film to prevent metal from ever actually touching metal while the engine runs. We pulled the oil pan, removed the rod caps and main caps, and inspected the bearing shells under magnification, checking for scoring, discoloration from heat, and material transfer. Both sets of bearings looked remarkably healthy. Car A's bearings showed a very slight bluish tint on the number 2 rod bearing, which typically indicates minor heat cycling rather than actual damage. Car B's bearings looked essentially like new, with the copper bearing material fully intact and no visible wear pattern beyond normal break-in marks. This is genuinely the area where full synthetic oil showed its clearest advantage, because bearing protection depends heavily on oil film strength holding up under extreme pressure, and synthetic base oils are simply more consistent at maintaining that film across a wider temperature range than the factory fill blend. Finding number 6, oil consumption and oil condition over the 2-year period, which we tracked at every single interval rather than just at teardown. Car A, running factory fill oil, showed measurably faster viscosity breakdown by the midpoint of each service interval when we sent used oil samples out for analysis. The factory fill blend showed higher levels of oxidation byproducts and slightly more fuel dilution, particularly during the winter months when short trips dominated the driving log. Car B's synthetic oil held its viscosity closer to the rated 0W20 spec even near the end of each interval, and showed lower total acid number readings, meaning the oil was breaking down more slowly and staying chemically stable longer. Neither car burned or leaked a meaningful amount of oil between changes. But if you're the type of driver who occasionally stretches an oil change interval by 1,000 miles because life gets busy, the data here matters, because the synthetic oil simply has more margin built in before it starts losing its protective properties. Finding number 7, the variable valve timing system, what Toyota calls VVTI, showed a small but consistent difference that is worth mentioning because it is rarely discussed in oil comparisons. This system uses oil pressure to actually rotate the camshaft phaser and adjust valve timing on the fly based on engine load and revolutions per minute. It relies on tiny oil control passages that can become restricted if the oil breaks down and leaves deposits behind. When we disassembled the VVT actuator on Car A, we found a small amount of varnish buildup inside the oil control valve, the kind of thin, sticky residue that forms when oil oxidizes under heat over time. It was not enough to cause any noticeable performance issue during the 2 years of driving, but it was there. Car B's VVT actuator was essentially clean, with no visible varnish in the control passages. This is one of those findings that will not show up on a dashboard warning light after 2 years, but multiply that varnish buildup over 8 or 10 years of ownership, and you start to understand why some higher mileage Toyotas develop that slightly hesitant, less responsive feeling during acceleration. So what does all of this actually mean for you as a Toyota owner deciding what oil to run? Here's the honest answer, and it's more nuanced than most videos on this topic will tell you. Toyota's factory fill oil is not a bad oil. It meets Toyota's own engineering specification, and it's formulated specifically to work with this engine's tolerances, its VVT system, and its oil pump characteristics. The engine that ran factory fill oil for 2 years was healthy, safe to drive, and would have easily gone well past 200,000 miles without a major failure. But the data doesn't lie. Full synthetic oil, particularly a higher quality formulation with a stronger detergent and anti-wear additive package, provided measurably better protection in the areas that matter most for long-term engine life: the rod and main bearings, the timing chain, and the internal cleanliness of oil-dependent systems like VVT. The difference wasn't dramatic at 24,000 miles. It was subtle, the kind of gap that widens slowly over time rather than showing up as an immediate problem. If you're the kind of driver who changes oil exactly on schedule, drives mostly highway miles, and keeps the car maintained by the book, the factory fill oil will likely serve you just fine for the life of a typical ownership period. But if your driving involves a lot of short trips, stop-and-go traffic, extreme heat, towing, or occasionally pushing an oil change interval a bit longer than you should, the extra margin that full synthetic oil provides starts to matter a lot more. It's not about one oil being good and the other being bad. It's about matching the oil to how the car actually gets driven, and understanding that the thin film of oil coating every moving part inside that engine is quietly doing more work than most owners ever give it credit for. If you made it this far, consider liking this video, giving it a thumbs up, and subscribing to the channel. It genuinely helps us keep doing teardowns like this one, instead of just repeating marketing claims. One more thing worth mentioning before we wrap up. During the teardown, we also checked the oil filters from both engines, cutting them open to inspect the filter media itself. Car A's factory filter, paired with the factory fill oil, showed a filter media that was noticeably more loaded with fine particulate by the end of its service interval compared to Car B's filter. This isn't necessarily a flaw in the filter itself, since both cars use the same filter brand and part number. It's more a reflection of how much material the oil was actually holding in suspension and carrying to the filter for capture. A dirtier filter at the end of an interval generally means the oil upstream was doing more scrubbing work, which lines up with everything else we found. The synthetic oil in car B appeared to be suspending and carrying away contaminants a bit more effectively throughout the entire interval, rather than letting them settle and bake onto internal components. We also want to be clear about the limits of this test, because a two-car, two-year comparison isn't a scientific study with hundreds of samples. It's a real-world snapshot, but it's a useful one because it reflects exactly the kind of ownership situation most Toyota drivers actually experience. The results track closely with what independent oil analysis labs have documented across thousands of samples over the years. Full synthetic oils generally outperform conventional and blended oils in high temperature stability, oxidation resistance, and bearing protection, while the practical difference at moderate mileage remains smaller than most people assume. Toyota engineers built this engine to run safely and reliably on the factory fill spec, and that fact didn't change based on what we found. What changed is our appreciation for just how much quiet, invisible work that thin layer of oil does every single time the key turns and the engine fires up cold. At the end of the day, the teardown didn't reveal a disaster hiding inside the factory fill engine, and it didn't reveal a miracle inside the synthetic one either. It revealed exactly what good engineering paired with good maintenance should look like. Two engines that both did their job, with one showing just a little more margin built in for the road ahead. If you're enjoying this video, consider watching the next one, where we open up a Toyota engine that skipped oil changes entirely for 3 years and show you exactly what happens when that margin runs out completely.